All right. Hey, everybody. All right. So the first thing I'm going to say is my slides are online. So if you like following along, you can do that there. There's not too much interaction going on, but you might be interested in checking out the reading list that gets involved in this, and everything's cited on the bottom of the slides. So yeah, as I said, my name is AG Dubs. You probably might know me from Twitter on that. And I'm coming to you from New York City. I am an engineer at the Mozilla Foundation. And what I work on there is open source software that's focused on universal open web literacy. And that's a mouthful, a lot like a lot of the things that are going to happen in this talk. But the simple way to think about it is I like making open source projects that let me think about thinking. And in particular, especially the type of thinking that happens when people write code. So something that I also like to do is I have a teaching background, and before I do anything, I like to say that I make mistakes. Everybody makes mistakes, and I'm probably going to make some during this talk, so hopefully you guys can respond with some empathy about that. All right, so let's talk about cows in space, right? Because that's what my talk is about. Does anyone even know what my talk is about? Probably not. The title's super weird, right? So yeah, cows in space? Maybe not. How about art? We've seen a lot of cool talks about art, so like maybe my talk's about art. This is some really cool internet art that I found. Super into it. But I'm actually not cool enough to talk about art. I don't really know a lot about it, and that makes me sad. So I'm going to talk about JavaScript. In fact, I'm going to talk about ES6. But before I do that, I'm going to take us on a little detour. And I know that's a bummer because I'm what stands between you and dinner and drinking and pool. But let's try and make it through this party before we have the actual party. So again, we're going to talk about abstraction. This wouldn't be a good computer science talk if I didn't kick us off with some Dijkstra. So let's do that. All right, and so Dijkstra says the effective exploitation of his powers of abstraction, and sorry about that bummer of a pronoun there. So let's say the effective exploitation of their powers of abstraction must be regarded as one of the most vital activities of a competent programmer. And so when we're saying this, what we're saying is like when we're doing programming, like I am doing programming, what I'm really doing is I'm abstracting. All right, and so what do we actually mean when we're talking about abstraction? And so Benjamin C. Pierce, in this awesome book called TAPL, Types in Programming Languages, defines the abstraction principle as each significant piece of functionality in a program should be implemented in just one place in the source code. Where similar functions are carried out by distinct pieces of code, it is generally beneficial to combine them into one by abstracting out the various parts. And so this probably shouldn't be like blowing anyone's mind. Hopefully not, at least, because I know that the joy of programming for me is being able to refactor things in just this way. Like it just feels good. And so hopefully you guys also enjoy that. But in this talk, I want us to think less practically about abstraction, maybe a little bit more academically, more theoretically. And so to get a better idea of abstraction in like an academic sense, I went to Wikipedia. Obviously, that's where you go. And so here in Wikipedia, it says, abstraction tries to factor out details from a common pattern so that programmers can work close to the level of human thought. I don't know, think about that for a second. And then leaving out details which matter in practice, but are immaterial to the problem being solved. And that's something I want us to flag. Immaterial to the problem being solved. We know that as programmers, our solutions are almost 50% defining the problem. And so as we walk through what I'm about to say, I want us to be thinking about what problem are we trying to solve with JavaScript. All right, so another detour, slight detour, all right? I was lucky enough to be the lead instructor at the New York City Web Development Fellowship, which is a boot campy type program that was run by a school called the Flatiron School, but funded by the New York City state government. And basically what it was students who either made very little money or unemployed were put through the 6-month program. They had very little background in programming, and then we got them jobs as junior developers. I agree that some of these bootcamp programs have some serious problems. We'll talk about them now. But I learned a lot, and I know that the students learned a lot. And these are the students right here. And one of the things that I learned was that for beginners, iteration is hard. And that's a big problem because iteration is something that as programmers we do quite a bit. It's a really critical task. It's a good concept. And so about 3 months before the fellowship began, I was at a Ruby user group in New York City with the dean of the school. And the dean had put these 2 blocks of code up on the board. And he said, look at that JavaScript. That is gross. Look at all that punctuation. You know, but look at this Ruby each. It's so expressive, even your mom could understand it. Sidebar, don't ever say stuff like that. Moms are smart and cool. Do not be rude. Yeah. So, as you might guess, I'm probably not going to end up aligning myself with the ideas of the dean. He had said, yeah, JavaScript, boo. All right, no JavaScript, Ruby. And so even though I'm not necessarily going to end up agreeing with him, he does have a really important point. And these 2 excellent hand gestury type computer scientists, Abelson and Sussman, who wrote a book we'll talk about a little bit later, they have this great quote which probably says what the dean was trying to say a lot better, which is that programs must be written for people to read and only incidentally for machines to execute. And I say this, and you probably can kind of agree about it, but how many times when we're writing code do we think more about the way it's going to execute on the machine, the performance, and not what's going to happen when someone tries to read it 6 months later? All right, we write programs, we use programs, we read programs, we maintain programs. Computers do some stuff over here. The computers don't really care. And so this is something that's really important. And once we can understand this, it actually presents us with a huge problem. Because hidden in this quote is a really interesting question. And that is, what does it mean to write a program for someone to read? What level do we start at? Because, you know, following instructions is really hard for some people. This is an actual picture of my door. Yeah, that did not work out, all right? So again, this is a problem, all right? And so with that, I want to share another story. So again, I'd been to this user group, but the jury was out for me at least about like Ruby, JavaScript, what's better. And I was sitting at my computer while my co-teacher was teaching iteration to my class for the first time. And I'm kind of like hearing out the side of the ear, headphones kind of slightly off. It's not going well. Like people are really not understanding how to use this each method. And like even though it's supposed to be so expressive, written in the English language, students are just simply not getting it. And so I had an idea. And with this idea, I decided to like kind of do something bold, which if you know me is not really that out of character. I walked over to the classroom and I was like, I'm going to hijack this class. And so I was like, guys, I have an idea and I'm not sure it's going to work, but let's try this. I want you to forget all the Ruby that you just learned. In fact, pretend Ruby doesn't exist. And then what I'm going to do is I'm going to teach you iteration in a language that you don't know. And everyone's like, that sounds like a bad idea. And I'm like, just give me a chance here. And everyone's like already frustrated and pissed off. So they're like, all right, fine, we'll do it. And so I proceeded to teach iteration using JavaScript. And this is why. The JavaScript for loop, even though it contains an intense amount of punctuation, it's very verbose, actually does something excellent in its verbosity. And what it does is it exposes the underlying concepts of iteration in its syntax. Iteration needs 3 things. It needs state, it needs condition, and it needs increment. And when you teach that, and it's right there in the syntax, suddenly everything clicks. It's not hidden in magic. You can manipulate it because you can see it. And then suddenly everything actually worked out really, really well. If we look at that Ruby each, sure it's there, but it's abstracted by the keyword each. And so the students didn't know what that did, and the for loop definitely showed them. All right, and so that was really, really awesome. And then we went back, we taught Ruby, we went on, we didn't teach JavaScript for another 3 months. But using JavaScript as a teaching tool helped people understand programming concepts in a way that was extensible to all different types of languages. All right, and so my my secret physicist boyfriend, Richard Feynman, he says something kind of similar and interesting about this, where he says, the real problem in speech is not precise language. The problem is clear language. It is really quite impossible to say anything with absolute precision unless that thing is so abstracted from the real world as not to represent any real thing. So we have a question here. We're at a weird intersection with programming. We're both doing things that are really precise, but then we're also humans coming from places in the real world where what we need is clear. All right, and so you may have recognized my Cows in Space painting as a bull's abstraction painting by Pablo Picasso, and he kind of chimes in on this. He says, there is no abstract art. You must always start with something. Afterward, you can remove all traces of reality. All right, and so we have a question here. When we're thinking about designing programming languages, particularly as tools for teaching beginners, where do we begin? All right? And so you may recognize this slide. I don't know if... Yeah, it's a good one. So I don't know if I've been to a conference that hasn't had this slide, so I'm just like doing my part here. But yeah, so this is the only curse word in the deck, unless I fuck up. I mean, anyways. So here we have something that says how to draw an owl. Step 1, draw some circles. Step 2, draw the rest of the owl. And this is exactly where we are when we think about designing programming languages. There are things in our languages now that do this to our programmers. And I'm not an artist, so I look at this and this like frustrates the hell out of me, right? And so imagine being a programmer and having a language do this to you. That sucks. All right? And that's something that we can work on. All right? These are both problematic. We are in a position here where we both need to do something that can connect us to the real world, but also is precise, and it makes us able to express things in our programming languages. We know that by using abstraction, we can be more efficient. We also know that by being explicit, we can make things more maintainable. And so we have a lot of conflicting things, and like, how do we mitigate that? All right, and so our journey begins in the place where we can connect those very precise idealistic things that we do in programming with the real world things, which is here. And so we're gonna start a little journey. You may say a personal voyage with my buddy Carl Sagan here. All right, so obviously we're gonna talk about cows in space. All right, so human beings are amazing pattern recognizers. We love making patterns, we see patterns. We're able to look at something like this, all right, and see that. All right? We're actually really terrible at things like books. Books have no visual rhythm. All right? We can't see anything, and we have terrible short-term memories. We much prefer things like lists, things that have some sort of visual cue. All right? Again, we see things like this, we see this. You do see it, right? I mean, somebody saw it and got a lot of people to agree with them. All right? So when we see these patterns, we make these patterns and we give them names. That's what an abstraction is, all right? But the thing we need to do is we need to be careful about the abstractions we make, because bad abstractions are big problems, all right? Here's an example. And maybe this isn't wrong, because I guess I do have a lot of opportunities to speak today, according to my horoscope. But there's also horoscopes like this, right? And so this is an abstraction that has become the ideology of a community. And we realize that the abstractions are our culture. And when we make bad abstractions, we have people sink time and money into things like this, which are not true because they don't expose the real mechanisms that underlie the concepts. All right? So let's talk about JavaScript. JavaScript has been a delightful programming language because it has lacked abstractions. All right? But that's all about to change. All right? So September 28th, 1980 was when JavaScript was invented. That's not true at all. I gotcha. Just kidding. It's actually when this amazing show Cosmos came out, and the point of Cosmos was to make science approachable to the entire population because they believed that those underlying mechanisms were important. And it wasn't about pop science. All right, it wasn't about that I fucking love science like Facebook meme or whatever. That's such garbage. All right, this was about real and like making it real for people. All right, and this is something that I think is really important. And in it, Carl Sagan says this: if you wish to make an apple pie from scratch, you must first invent the universe. And so I said, if you wish to learn ES6 from scratch, you must first invent the universe. And that wasn't Carl Sagan, that was me, but I kind of wish I had his backing because that'd be really cool. All right, so let's talk about ES6. All right, from the spec we read, ECMAScript syntax is relaxed to enable it to serve as an easy-to-use scripting language. All right, and relaxation is super cool. I've been relaxing. We're all at this great resort. Who's been relaxing? Yeah, sweet. Relaxation is not always the right message. Not always what we want to hear, right? So is the job of JavaScript to be easy to use? Is that the problem we're solving? Is there like not another easy to use language? That doesn't seem very ambitious, right? I mean, we really need to ask ourselves, what is JavaScript trying to solve, really? Like, when we look back at JavaScript as some like weird historical artifact, what are we gonna look at it as? What will JavaScript's legacy be? And like, that's a pretty heavy question, and I'm not an authority like to answer it. But if somebody asked me, and I do think you should also ask yourselves, I'm gonna say it probably has something to do with this. And this is a tweet from Laurie Voss of NPM, and he says, fundamentally, it's hard to think of a compelling reason a brand new web dev would learn 2 languages when they can just learn JavaScript. If I could pick any language in the world to use on both server and client, it might not be JavaScript, but we don't get to pick. All right? So this brings me to our Danger Will Robinson robot, where I'm gonna warn you about aliens, and those aliens are ES6 classes. So I'm gonna start off by saying that sugar makes me sick. Like, it actually makes me sick. I have type 1 diabetes. But also, syntactic sugar makes me nervous. It makes me really nervous because usually when I see syntactic sugar, it probably means there's some sort of obfuscating of the underlying concepts. And I've already kind of made my point that I'm not into that. All right, and so let's go to the script. Even though ECMAScript includes syntax for class definitions, ECMAScript objects are not fundamentally class-based. Okay, so we have a way to talk about something that's not real. So you might not need class syntax. All right, so this is my favorite person that I quote in this talk. He's just... if you remember anything from this talk, please remember this quote or something about Doritos, either one. He says, remember that all models are wrong. The practical question is, how wrong do they have to be to not be useful? All right, so how wrong are we? All right, in a class-based, object-oriented language in general, state is carried by instances, methods are carried by classes, and inheritance is only of structure and behavior. All right? In ECMAScript, the state and methods are carried by objects, while structure, behavior, and state are all inherited. Okay, so that's actually kind of like a mouthful, and if you're not into reading like all of this stuff, you maybe don't really know what this means. So I've got a metaphor for you, and it's from this guy named Regenwald, who you might know from Twitter for saying awesome things like this. He wrote a great blog post, and I'm not going to read this to you, but the idea is that when we teach classes, classes are generally understood as blueprints. The class is a blueprint, and then we make an object from that class. That object could kind of be understood as a house. In JavaScript, we have something different. JavaScript classes are model homes. So you can leave them empty, but someone can move in. Yeah. So what we have here is JavaScript classes they're objects. They're not really classes. And when you hear me say this, you might hear me say, go home DC39, you're drunk. But this is not a hate talk. And I also want to say right now that, I mean, this happened to me today, but like, never criticize without offering something. And I love the work that people who work on open standards and open source projects do. So this is the moment I'm going to say shout out to all the work that you do. It's thankless, and so good on them. I love them all. But I do have a perspective to offer that I think a lot of people don't have. And I'll also say something I like to offer is a really cool way to criticize me right now is to say, what even is a class? All right, and I studied a lot of this, and if I had 30 more minutes, which I totally don't, I would talk your ear off about this simula. Shout out to the person who actually knew what that was. If you want to hear more, talk my ear off at the pool. I would love it. But what I would do want to say is, in JavaScript, we might be trying to do maybe too much and not really be any of the things that it is. This is a real place you can go to outside Madison Square Garden in New York City. So yeah, the perspective I want to offer is that of an educator. And so Leslie Lamport has like a really awesome presentation called Thinking for Programmers. And in it, he speaks a lot about writing as a precursor to doing programming. And he quotes this, and it says, writing is nature's way of letting you know how sloppy your thinking is. And so what I want to offer is this. Teaching is nature's way of letting you know how sloppy your understanding is. And it's through teaching that we understand how difficult the concepts that we are building in our languages are. And so how do we deal with this? So this was Abelson and Sussman, and they wrote this tome. And it was really important because it was the first book that said, we need to teach programming concepts, not syntax. And immediately what we should hear now is a conflict. In JavaScript, we have a syntax that doesn't expose the underlying concepts. So it will be a nightmare to teach classes. It's going to hurt. All right, JavaScript will be the introduction to programming concepts for an entire generation of developers, regardless of whether or not we want it to be. All right? And so when we think about things being immaterial to the problem being solved, we need to realize that JavaScript is a teaching language. No matter what, it can be a lot of other things, but it is a teaching language. All right? So Peter Van Roy is an excellent computer scientist. He's really awesome. He wrote a follow-up to that book, the SICP, and he said we need to teach programming as a unified discipline. All right? We need to understand that programming languages are tools. All right? And these tools address problems. And so when we solve those problems, the connection of the problem and the solution is called a paradigm. And so programming languages can be single paradigm, multiple paradigm, but this means that there's not a bad programming language. There's just a good programming language for the job. All right? Problem, solution, pairs, paradigms. All right, and so in this vein, what Peter Van Roy says is that we should use something called the kernel teaching method, where a good way to organize a programming course is to start with a simple language and then to extend the language gradually. When he teaches his students, they start with nothing, literally nothing, and then they build everything up based on feeling the need to have that abstraction, feeling the pain. All right? And in this sense, we understand that building those abstractions is building this universe. The set of abstractions that we have in a language are the universe. All right, so obviously what I'm saying is everything beginner should write a kernel language, right? This is a really, really bad idea. Let's not do that. Instead, what we need to use is the creative extension principle. We don't have to start from the beginning. We can't start from the beginning. But what we can do is we can understand that we need to build abstractions when we feel the pain of them. All right? And this is not like a new concept necessarily. All right? We know as software developers that we should really only implement things when we actually need them, never when we just foresee the need for them. All right? However, this has been a really strange concept in computer science education. All right? So prototypal inheritance is a big part of the JavaScript universe. All right? It's how the apple pie gets made. Vegans, yay. All right? So basically what I'm trying to say is, as we are thinking about programming languages and programming language design, we need to keep an educator's perspective. And I have this slide in here just so that if you ever look back at it, it's kind of a summary. But in the time that I don't have, which I don't care about, I am going to leave you, sorry, you guys can yell at me later, with something that I think is really important, because we're all together now. And these are the questions that we really should be asking ourselves. So we should take this opportunity. And what I want to ask is, what do we even mean when we talk about programming? All right? One of my favorite philosophers, Martin Heidegger, wrote a book called What is Called Thinking? And in it, he asks, or says, the most thought-provoking thing in our thought-provoking time is that we are still not thinking. And so it might sound a little kumbaya, but I am dead serious. I want you to ask yourself, are we programming yet? All right? If what we mean by programming is really this awesome feeling of abstraction, how much time do we spend doing that instead of typing punctuation into our terminal? All right? A lot of really awesome people are doing things on this axis. There are people who are radically rethinking these things. They're going from, not even typing into dragging and dropping components. All right? But all of this is happening in the academy. And I'm pissed because I cannot afford grad school. But at the same time, there's no reason we can't be doing that here in the industry. So Thomas Kuhn is an amazing philosopher of science, and he says scientists work from models acquired from education and through subsequent exposure to the literature, often without knowing or needing to know what characteristics have given these models the status of community paradigms. All right? We need to think about what our paradigms are. I don't want us adding the features that are much like an Abercrombie shirt in middle school. We do not need to be the cool kids. We can think about that, all right? So we have an awesome opportunity to more radically think about how we extend JavaScript. We're in that period right now. It's being written, and this is a really awesome time. And so I'll leave you with this. It is far better to grasp the universe as it really is than to persist in delusion, however satisfying and reassuring. So let's reconsider our ontology. Let's do it often, and let's stay beginners. Thank you very much.